All right, so we're going to have a binomial with two terms, and we're going to raise it to a power. And so this is kind of weird because we've been talking about rational, and all of a sudden we're going to talk about polynomial. It's fine. The technical title for this lesson is equivalent representations of polynomial and rational. So this is an equivalent representation when you expand a binomial. Okay, so typically in pre-calculus we would have already spent some time squaring binomials, but I don't think we really have. If you look in that cabinet. So do you all remember a shortcut for squaring a binomial? Maybe from Algebra 1 or Algebra 2? Don't? It's okay. I'll remind you. So if we have two terms and we want to square them, we can't just square the first and square the second. That just never works for squaring a binomial. But the shortcut is you can take A and square it. And then you multiply these together and multiply by 2. And then you square B. So that's the shortcut. I love using the shortcut. I hardly ever actually multiply it all out that way. It just takes way too much time. And so if I was going to take this one and use the shortcut, I would square x. I would multiply x times 3 and multiply that by 2. And then I would square 3. All right. Now, it's really not that time-consuming or tedious to do it by hand. So to do it by hand, you would distribute the x, get x squared, multiply it, that gives you your 6x, and then 3 times 3 gives you 9. And it's not that tedious. However, when you go to cube a binomial, it starts getting a little bit more tedious. And so what you would have to do is multiply what we just got by another x plus 3. And that involves distributing the x 3 times, distributing the 3 times, and then combining your like terms. But I'm going to show you a shortcut. If I want to take a binomial and I want to raise it to the third power, I can just cube the first one. Right? And then where this one had a 2, this one is going to have a 3. And this is definitely more complicated. Then the A is going to be squared. And then you're going to multiply that by B. Right, and then we have another 3. The A is going to be raised to the first. And the B is going to be squared. And then we're going to cube B. All right, so let's see what that looks like. I would go back to this one. I'm going to cube x. All right, then it's going to be 3. And then the x is going to be squared. And then we're going to multiply it by b. And then I have another 3. And then we're going to have x to the first, 3 to the second, and then 3 to the third. I don't know, maybe this isn't easier this way for cubing. All right, so to get the final answer, I need to multiply these together and get 9x squared. And then I'll multiply 3 times that. And then 3 cubed is 9. It's 27. All right, now, again, I saw some people were just going ahead and doing it the other way where you distributed. And that's fine if you're going to cube it and not use the shortcut. But when you if we wanted to take it and raise it to the 7th power, that is going to be a ton of work. We would have to keep multiplying by x plus 3 7 times. And that would be, like, not even worth doing for sure. Yes, ma'am.
If you did do the seventh power, would you just change the 3's to 7's and the 2's to 6's?
We do change it, not necessarily exactly like that, but yes, you are going to change it. You're going to have a similar pattern, just with different numbers in the front. So before we get into like how you do this, what do you guys notice about the powers on A as you go through the problem? It starts off by 3, and then what happens? They go down. Go down until it's like A to the 0. All right, what about the powers on B? They go up. And if we actually wrote the powers here, the power is either 3 or they add to equal 3. And that's going to be consistent no matter what we're raising it to. All right, so what we're going to use is called Pascal's triangle. Pascal is the purple guy back there. He lived, I have no idea, is it the 1600s? He lived in the 1600s. He's a genius. Someone in my last class doesn't like him, but I think he's a genius. And so these numbers, this 1 and 2 that were here, this is a 1, 1, 2, 1, came from Pascal's triangle, 1, 2, 1. And then when we were doing the cube, it's 1, 3, 3, 1. That came from Pascal's triangle also. And so I'm going to show you a couple more rows, and I'm going to see if you guys can figure out what I'm doing, and you'll be able to create Pascal's triangle anytime you want to. All right, so row 4 is going to be 1, 4, 6, 4, 1. Row 5 is 1, 5, 10, 10, 5, 1. Do you guys see what I'm doing? I'm using the previous row, if that helps you. Does anybody see it? It's hard to explain. This is exactly what they did last period. So the outsides are always 1. How did I get this 5? What did I do? 1 and 4. You add those to get that one. And then to get 10, you add 4 and 6. And then same thing on this 10, it's 6 and 4. Does that make sense? All right, you guys do row 6 and 7. And we could keep going, but we're going to stop there. You guys, I think, get that idea. And so those are going to give you the coefficients that you're going to multiply by when you're doing these expansions. And for me, anytime I trying to figure out what row I'm in, it was kind of like Tara said. So if it's a 3, that means it is being raised to the 3rd power. If the second number in the row is a 4, it's being raised to the 4th power. So I just look at the second number, and I know that's the power I'm using to do that problem, okay? All right, so let's do some of these. So the next page I have 7 rows, I guess technically 8 if you count row 0. All right, and we're going to use this triangle to expand x plus 2 to the 5th. So without this, if I wanted to expand it, I'd have to multiply it by itself 5 times, which would be kind of terrible. So instead, I'm going to use the shortcut. And for this one, I'm going to look, and whichever row 5 is the second number, that's the row I'm going to use. All right, so I'm going to start off with the 1, which we don't have to write. X to the 5th. So it's always whatever term this is raised to that power is your first term. All right, and then a plus. I'm going to go to my Pascal's triangle. And the first number I see, or the next number I see is 5. So 5 is multiplied by the x. And the power on the x should start going down. And so now it's a 4. And the power on the 2 is going to start going up. Okay, so in this case, A is like x and B is 2. All right, and then we have a plus. And then what's the next number I need to write? 10. We're looking at the triangle 10. All right, and then we have x. Power should start going down. The power on the 2 should start going up. Are y'all good? What's
How do
wrong?
you know where you got to put the 2 at?
I don't know what that means.
Like, why is the 2 going there instead of like?
In the front? I mean, you could write it anywhere. It's multiplication, so where do you want to write it?
No, I'm just confused. Like, what makes it B?
Oh, it's this 2.
Yeah, why? I know it's.
Like, what's the formula you're using to, like, is it like
Oh.
A, then A and B?
Yeah,
plus
so it is.
AB?
It's like, this is basically 2 to the 0 here.
So it's just AB.
And with
plus
the A is
minus
going down
AB
and the
plus
B is going
minus
up.
AB
Yeah.
plus minus. Okay.
Yeah. You got it?
Yeah.
Okay, thank you, Miranda. All right, and then what's the next thing? 10 again. And then the x power is going down. The 2 power is going up. Just keep that pattern. Pretty much everything in math, all mathematical concepts are developed from patterns. And so this is the pattern for expansion. All right, now, if this was a question, there will be some sort of AP question on the multiple choice question that uses this, I think. Yes, ma'am.
Sorry, I just wanted to ask whether it was, how to get the 2 to, like.
To the 5th at the end? Okay, so the power on this 2 just keeps going up all the way until you get to that power. All right, and then just double check your powers. Make sure in each term that's separated by addition that those add to equal 5. They're either 5 or they add to equal 5. So I feel like if this was a question on the multiple choice where you couldn't use a calculator, I think they might leave the answer in this form instead of having you multiply it out. This one is actually not that hard. We can do it in our head, but it'll either be on the calculator or they'll leave it like this. You good? Okay, and so I'm going to go ahead and finish it off though because these numbers aren't difficult to do in our heads. So to get the coefficient in front of x to the 4th, I'm going to multiply 5 times 2 to the 1st, or just 5 times 2. All right. To get the coefficient for x cubed, I'm going to multiply 5 times 2 to the 4th, or 5 times 4. And then I'm going to do, 10 times 4. And then for the next one, it's going to be 10 times 8. This one isn't as easy to do in your head. So 2 to the 4th is 16. 5 times 16 is 80. Do you guys know what 2 to the 5th is? It's 32. That's the reason why I think they would probably leave it in that purple form if it's a non-calculator question. Just to see if you know the expansion rules. All right, that's it. That's what we would get if we took x plus 2 and I multiplied it by itself 5 times. It's a lot. Okay, the next one is more difficult for 2 reasons. One, because there is a 2 on the x, and so we have to be kind of careful when we're raising that to all the different powers. And there's also a negative here. So I'm even though this is the second one, I'm still going to go kind of slow on it. All right, which row are we going to use? The 4th one. The one that has a 4 is the second number. All right. And so we'll use the 1, and then we're going to do 2x to the 4th. And we need to put that in parentheses. The 2x needs to be in parentheses, and the fourth is on the outside. All right, and then we have our coefficient of 4. And now 2x is going to be raised to the third. And then what is negative 1 going to be raised to? The first. All right, and then we have a 6. Two x is raised to the second. Negative 1 is also raised to the second. So I would recommend that every time you're done, you just look and just double check your exponents to make sure that they all add up to be whatever your power is here. And they do. All right, and then one more thing. In my last class, they got a little confused. Like they were thinking this number needed to be raised to the third, and this number needed to be raised to the second. Those numbers you get from Pascal's triangle, they never get raised to powers. So only thing that get raised to the powers are the things inside the parentheses. All right, now you are welcome to try and figure this out in your head, or we can use a calculator, either one. This isn't too terrible because it's just 2's and 1's. But 2 to the 4th is 16. So that means 16x to the 4th. All right, and then we need to multiply 4 times 2 to the 3rd, which is 8, times negative 1. All right, and then 6 times 4. What about negative 1 squared? What is that? Positive 1, good. So it's basically just 6 times 4. What about negative 1 cubed? Negative. So I feel like we've talked about that so much with our little sets of parentheses that you guys, that is something you are probably pretty good at. So this is really just 4 times 2 times negative 1. And then negative 1 to the 4th is just going to be positive 1. What do you guys notice about the signs here? The signs? They alternate, good. So it's gonna, if you have a minus there, it's gonna alternate from positive to negative whenever you're done. This is another thing to kind of check for. All right, what questions do you guys have? Okay, there is one more thing we're gonna do, and we're not gonna do the whole expansion. We're just gonna figure out the coefficient of one term. And so if we expanded x plus 5 to the 6th, we want to know what number would be in front of x to the 4th. Okay, so I am just going to write down that row so I can talk about it while we're doing it. It's up to you whether you write it down or not. All right, that's the row we're going to use to raise something to the 6th. And the only term we care about is x to the 4th. So if you're looking at these, how are we going to figure out what coefficient goes with x to the 4th?
The fourth one from left to right.
So you want to start at the back or the front?
The front.
Okay, so the front, this one would go with x to the 6th. This one would go with x to the 5th. And this one would go with x to the 4th. That's how I have to do it. I don't know if there's a better way. I just write it out so I know I'm doing it right. Does that make sense, Kennedy?
Yeah.
Okay. So I know it's for sure going to be a 15. That's not my answer. It's going to be 15 times x to the 4th times what? Absolutely. How do we know it's the second? It has to add to equal 6. Good job. All right, so I think this would probably be one you would do on the calculator. I don't know. So you would do 15 times 25, which isn't impossible. It's just not an algebra, or it's just not a pre-calculus skill, being able to multiply those numbers. And so the answer would just be this coefficient. Now, I'm going to go ahead and tell you, I put one of these on your test, but on the test, I asked for the whole term, not just the coefficient. So the answers on the test would look like this. All right, and then let's do one more like that. So we need to go all the way to the 8th. So I'm going to write down what that is. Almost didn't give myself enough room. All right, now we can count from the front or we can count from the back. So you guys do whichever you need to figure out which one of those coefficients from Pascal's triangle we would use for the x cubed term.
28.
Well, if we're doing it from the back, this would actually be x to the 0, x to the 1, x to the 2, x to the 3. Because the very last term doesn't have an x. Or you can start from the front. Either way, I don't care as long as you can get it. As long as you can get there. This is the guy we want. All right, see if you guys can figure this out. And you can use the calculator in the end because this gets it's huge. This is a 5-digit number in the end.